Okay, we're going to look at composite functions today. So a composite function is one function inside of another function. So I have f of x, which is x plus 3, and I have g of x, which is 10x over x plus 1. And I want to throw out f of g of 4. So I'm going to start with the inside, g at 4, and I'm going to figure that out. So I'm going to go g at 4, and that is equal to 10 times 4 divided by 4 plus 1. So 10 times 4 is 40, divided by 5 gives me 8. And then I want to take that answer and do f of that answer. So now I'm going to do f at g of 4. So now that means I want to do f at 8, because g at 4, the answer was 8. So now I'm going to take 8 and plug it into f of x. So now I have 8 plus 3, and that gives me 11. Another way to write a composite function is f of g of x. A lot of people say fog or goff over here, but really it's f of g of x. So another way to write this is f of g of x. So now I want to do f of the g of x function. So the g of x function is sine 3x plus 1. So now I'm going to take the function sine of 3x plus 1, and I'm going to put it into the f function. So that means wherever I see an x in the f function, I'm going to replace x with sine of 3x plus 1. So this means 2 sine of 3x plus 1, and that's squared, plus 15 sine of 3x plus 1, and we have minus 9. So I can simplify that as sine squared of 3x plus 1 plus 15 sine 3x plus 1 minus 9. Now I want to do the reverse. I want to do g of f of x. So I can rewrite this as g of the function f of x. So I'm going to replace f of x with 2x squared plus 15x minus 9. And now I'm going to plug this into the g of x function wherever I see an x. So I'm going to get sine of 3, and now I see an x and I'm going to replace it, and then plus 1. So this is sine of 6x squared plus 45x minus 27 plus 1, or sine of 6x squared plus 45x minus 26. Okay, if I look at the next one, I now have 3 functions. I have f of x, g of x, and h of x. So I want to do f of g of h of x. So what I do is I start on the inside, and I'm going to worry just about the g of x and the h of x. So I'm just going to start with g of h of x, and I'll simplify that, and then I'll do the f of x after. So h of x is 1 over 7x. I'm going to plug that into the g of x function wherever I see an x. So I have 2, 28. I have 1 over 7x plus 7. So that gives me 2. And again, this step is not necessary, but you can write it if you want. 28 over 7x plus 7, or 2 to the 4x plus 7. Now I need to do f of g of h of x. So now I need to go and actually do the whole function. Well, I know what g of h of x is. It equals to 2 to the 4x plus 7. I'm now going to take that and plug it into the f function wherever I see an x. So now I'm going to do 2 to the 4x plus 7 cubed plus 5. Four can be written like that for the time being. When you have a power to a power, you can multiply. So I'm going to do 4x and 7, and I'm going to times it by 3. So that gives me 12x plus 21, and then plus 5 on the end. But I can rewrite 4 as a base of 2. So I often try and look and see, okay, what is the base here? Can I do something with the number in front? And in this case, I can. So I can write this as 2 squared. 2 12x plus 21 plus 5. Again, when you multiply, you can add. So I have 2 to the 12x plus 23 and then plus 5 on the end. Okay, if we continue on, okay, so I have my functions f of x and g of x, and I want to prove that f of g of x is equal to tan squared x. So I'm going to draw my t-chart. So on this side, I have f of g of x, and I want to prove that it equals to tan squared x. So I have f, g of x is secant squared x. And I would like to plug that into f of x. So again, wherever I see an x, I'm going to insert secant squared x. So I have secant squared x minus 1. Well, secant is 1 over cos. So I can write this as 1 over cos squared x because secant was squared. Cos is also squared, minus 1. In order to simplify these, I need a common denominator. So I'm going to make a common denominator of cos squared x. Well, to get 1, this numerator also has to be cos squared x. Because I have common denominators, it means I can subtract the numerators. So I have 1 minus cos squared x all over cos squared x. 1 minus cos squared x is just a rearrangement of the Pythagorean theorem identity. And because it's a rearrangement, it means that I can use that to simplify this. And it equals to sine squared x. And this is over cos squared x. And then that gives me tan squared x if I simplify it. So then I can say that therefore left side equals right side, and then I will write QED. Okay, we're going to look at the last one. Again, it wants me to prove that a plus b of c of x is equal to 3x minus 6. So again, I'm going to draw my t-chart. And I have a plus b of c of x, and that equals to 3x minus 6. So what this means is it means a of c of x plus b at c of x. So it means a and c of x is 4x minus 3 plus b, and again c of x is 4x minus 3. I want to plug this one into a, and I want to plug this one into b. So that means log base 2, 8 times 4 of x minus 3 And it means log base 4 of 4x minus 3. The base is 2, and I know that I can change 8 and 4 into base 2. So what that means to do is it means that we're going to do 2 cubed times 2 squared x minus 3 log base 4 of 4x minus 3. I have log base 2. I have 2 to the 3. This I'm going to multiply, so I have 2 times x and 2 times 3, which will give me 2 to the power of 2x minus 6. And this is log base 4 of 4x minus 3. When I multiply powers of the same base, I can add the exponents. So I have log base 2, 2x minus 3, plus log base 4, 4x minus 3. This is a base 2 and this is a base 2, so the answer is the exponent. This is a base 4, this is a base 4, so the answer is also the exponent. So I can add, and I get 3x minus 6. We can say, therefore, left side equals right side, and we have QED.